Hello, and welcome to Out West, the official podcast of the Western Governors Association, a bipartisan organization representing the governors of the 22 westernmost states and territories. I'm Jim Ogsberry, Executive Director of WGA. Today's episode is the second in a series about Oregon Governor Kate Brown's initiative to create an electric vehicles roadmap for the West. As chair of WGA, Governor Brown is pursuing this initiative to promote enhanced planning, siting, and coordination of electric vehicle infrastructure in the West. Electric vehicle technology is advancing rapidly to keep pace with increased consumer demand. EV cars, trucks, and buses are becoming more economically viable because of innovations in battery technology, infrastructure modeling analysis, and charging and hydrogen fueling systems. WGA policy advisor Kevin Moss recently spoke with Eric Wood, a research engineer at the National Renewable Energy Laboratory's Center for Integrated Mobility Sciences, Alex Keros, a lead architect of EV infrastructure at General Motors, and Kim Okafor, a strategic business development manager at Trillium, a Love's company, to learn more about the researchers and companies working at the forefront of EV technologies and innovation in the West.
Hi, everyone. Thank you for joining us today. This is the second podcast episode as part of Governor Brown of Oregon, her Electric Vehicles Roadmap Initiative. Today's episode is going to look at innovations within the electric vehicle sector. Our first speaker is Eric Wood from the National Renewable Energy Laboratory. Eric, can you give our listeners a little bit of a sense of how the National Renewable Energy Laboratory functions and how you do research on sort of pre-market technologies, and then how does the lab help bring those technologies to bear and get used in a market sense?
Yeah, so I think nationally, NREL is probably best known for the work that we've done in the renewables space around wind and solar, particularly. So kind of that basic fundamental technology development role is something that we serve. So NREL is the research lab of the U.S. Department of Energy. And so within the EV space, that kind of fundamental technology-based research really focuses on things like electric vehicle batteries, power electronics, electric machines for EVs. Also, charging infrastructure is another big area of emphasis at NREL. And so we've been involved in things like standards development for the megawatt charging standard, thinking about what infrastructure may look like for heavy duty vehicles and electric semi trucks, things like that. So the technology development is certainly really core to our mission. I would say that integration and deployment are also central to the work that we do. So NREL is really unique, I think, as are a lot of the national labs, in that we get to sit kind of at the cross section of different industries. And so with EVs, we're sitting at the cross section of transportation communities, automotive communities, and electric power communities as well. And so trying to bring those groups together and tackle the different integration issues related to electrifying transportation is something that's a really unique role I think that NREL fills.
So you did mention one area I want to dig into a little bit, which is just batteries in general, but I know that you're sort of on the modeling and the software side. So I was hoping that you could discuss your development of NREL's battery lifetime and analysis simulation tool for lithium-ion batteries and just how that tool has helped with recent developments of batteries. And obviously there are a lot of, changing components and how they function and things like that. But if you could just discuss that tool a little bit, I think that'd be great.
Yeah. So the tool goes by the acronym of BLAST. I actually have to credit a former colleague, Jeremy Neubauer, for coming up with the acronym. It's a catchy one, I think. So BLAST is essentially a physics-based semi-empirical model of battery degradation that's been applied both to electric vehicle applications as well as stationary storage applications. One of the challenges with trying to forecast life for EV batteries is that they are exposed to lots of different use cases, different ambient conditions, different driving and charging profiles. And so one of the benefits of the BLAST software is that we can take a relatively limited set of test conditions, most of which occur at steady state, one cycle a day, every day for a year or something like that. And we can develop and calibrate a model such as BLAST that can be used then to explore how a battery might respond in terms of its usable power and capacity over the lifetime of the pack under different use case scenarios, including primary use as well as secondary use of automotive packs and stationary applications is kind of a unique element that we've used BLAST for at NREL. And so the tool is primarily maintained by the lab and used for studies within the Department of Energy. But we also collaborate with electric utilities and automotive manufacturers to help them design packs and batteries that can meet the needs of consumers and also be performant while doing so.
For sure. Yeah, I think your point about that these batteries are put through a ton of different use cases, from a residential driver, maybe like myself, who maybe almost always charges overnight, to maybe they're being used in a heavy duty context where you're trying to get a lot of charge in there really quickly and then get a truck back out on the road. I can certainly appreciate that those different conditions are hard to model. So I want to touch on one other tool that you've been involved with at NREL, which is NREL's electric vehicle infrastructure projection tool, which, as I understand it, kind of helps model how much demand a certain set of EV drivers might put on the local grid. And so can you just talk about that tool a bit, and maybe how either states or utilities or private industry have used it to help inform their investments?
For sure. Yeah. Infrastructure is a really, I think, exciting area for us at NREL. So it's tempting, I think, for some people to look at infrastructure. While we all acknowledge that it's really critical for the increased sale of electric vehicles, it's sometimes tempting to oversimplify it and say, well, if we transition or flip gas stations over into EV charging stations, shouldn't that be all it takes, right? But that kind of approach really simplifies the problem. It overlooks things like the ability of an electric vehicle to charge at home. That could displace a lot of the demand for public charging that we see today from gasoline vehicles. It also neglects the fact that electric vehicles have very different range and refueling kind of attributes than what you see for gasoline vehicles. And the way that they integrate with the electric grid also makes it really important to consider the different ways that they can be charged, both fast charging and slow charging as well. And so EVI Pro is a tool that we developed to try to answer some of these questions about what kind of charging is necessary, how much charging, and where should it be located. The tool is available in kind of a really detailed way through NREL, but we also acknowledge that the topic of infrastructure planning is a very broad topic with lots of stakeholders making decisions, sometimes on really limited information. And so in addition to EVI Pro, we've also developed a light version of the model that's available online. So if listeners Google EVI Pro Lite, they'll be taken to the Department of Energy's Alternative Fuels Data Center. So this simple tool, we think, really helps make the model more accessible to a broader community and also meets the needs of lots of policy individuals where they're at, and provides the tool hopefully in an intuitive manner.
I do want to dig into energy storage systems a bit. I think that's sort of an exciting new frontier with EV charging and maybe mitigating some of the demands on the grid. So do you see any potential there for charging station operators to integrate those technologies? And is NREL doing any research there?
Yeah, absolutely. So I think there's a lot of potential for storage to help bridge the gap, so to speak, in utilization. So one of the big challenges with deploying infrastructure today is that until the vehicle market catches up, so to speak, or until there's a larger number of electric vehicles on the road using these stations, we can anticipate, and we've seen that utilization for some stations is really low. And people talk about infrastructure in terms of the chicken and the egg, right? But in my opinion, I think that the infrastructure really needs to lead. I don't see a use case really for electric vehicles where you try to sell them to people and tell them that the infrastructure will come later, right? I think it needs to be a solution from day one when someone purchases the vehicle. So while we've got this gap between the vehicle market and charging networks, this low utilization makes it really challenging financially for network operators to maintain their infrastructure in a sustainable way. And so the demand charges that they see, at least in part, can be offset by the presence of on-site storage, where the stationary battery, can be charged when it's cheap to do so during the day and at low rates, and then be used to help supplement power from the grid when vehicles do show up to charge. So we've got projects that have looked both at distributed storage and also distributed generation as ways to improve station economics, and are currently going through a relatively large effort with the Department of Energy to try to design purpose-built storage technology that can be used for EV charging stations specifically under an array of use cases. And this whole idea of grid integration, I think, is a really good example of kind of the interdisciplinary nature of the work that goes on at NREL.
Can you just quickly discuss any of the research that NREL is conducting and how it may help support smart, effective investments in EV fleet infrastructure?
Yeah, I think fleets are a really important area for focus. if we look forward, 5, 10 years in time and think about the cost of these vehicles continuing to come down, the potential for these vehicles to have much lower total cost of ownership than the incumbent gasoline technology is there. And so I think that that's a good role to try to help fleets understand what total cost of ownership could look like and also what some of the challenges are. I think going back to infrastructure, that certainly can be a big challenge. The presidential administration right now has put out goals for broad electrification of the federal fleet. And that's an area where NREL's been actively involved with, doing research and supporting the federal fleet for many years. And the challenge there with electrifying so quickly is that you're talking about bringing in a lot of power, electrical power, to depots and the places where these vehicles reside overnight in areas where it may not have been there previously. And so the potential exists for really high capital costs to install charging infrastructure at some of these facilities. And so that's an area where we think there is a potential bottleneck and think that additional research and work with electric utilities as well is necessary to try to make ready some of these sites for these higher levels of electrification that we're all talking about.
All right, well, our second speaker is Alex Keros. He's the lead architect for electric vehicle infrastructure at GM, and he's going to build off of some of Eric's comments and help give us some vehicle manufacturer perspectives to this conversation. So this episode has kind of a general innovation frame to it, but I think one area where you all can offer an interesting perspective is just in, what are the innovations within the customer market for EVs and how customers are thinking differently about purchasing an EV versus how they would have purchased internal combustion engine maybe a few years ago. So can you just talk generally about how GM is assessing that challenge and trying to meet some of these new consumer demands for electric vehicles, and if you've pursued any innovative strategies with partnerships or internal planning, whatever it may be?
Yeah, no small question there. The most basic level, it's a car, right? And it really has to meet the needs of transportation, whether it's a retail customer or a fleet customer. Obviously, it's a new technology. There's a lot of questions. There's a lot of newness, where you're almost turning the car into not just a transportation, but almost a platform to be able to do. Even Eric and you were sort of discussing the role that an EV might play in grid services. But on a couple levels, we have to really rethink that overall customer experience and how they interact with the vehicle on a daily basis. So infrastructure obviously is top of mind for a lot of us. On one hand, when you think about fueling an internal combustion engine, we're all familiar with it. It's all pretty obvious. Go to a gas station. But when we start thinking about, for example, an EV, it's much more likened to charging a cell phone and thinking about how you charge a cell phone than it is, that gasoline station. You plug it in at night, you fill it up, you wake up in the morning, it's available. People often ask me, how long does it take to charge a vehicle? Overnight takes me about 5 seconds because I get out of the car and plug it in and walk away. But go throughout your day, you use it, maybe you use it more, maybe you use it less. You need to find a plug throughout the day, just like your cell phone. So we really do have to think about these experiences in helping customers come along for the ride, helping our dealers come along for the ride, helping fleets come along for the ride to be able to do those sorts of things. So a fair amount of different types of innovative efforts. Again, on the dealer side of thing, we announced a digital retail sort of platform to make it much more seamless for people to purchase EVs, to understand, to engage, helping dealers get better educated and have the right tools so they can present these types of information to customers. We think about getting deployment of infrastructure and making sure charging is out there. Made an announcement last July with a relationship with EVgo to partner to add, again, additional charging stations. And while it's important to get those charging stations out the door, we want to make those available to every car, every customer. Frankly speaking, it's also about integrating that technology such that we're meeting expectations. The Hummer with higher power, 300 kilowatt above charging, being able to do that, making sure those stations out there. How do we get charging in places that people are already at so we can leverage our data in an anonymous, aggregated way to say, all right, Kevin, Eric, all you guys, are we all going to the same grocery store every weekend? And is that the place to put charging? Or are we all going to the gym and your car's already there for an hour and being able to get and replenish charge. So we're rethinking how we integrate sort of our data with that customer experience, thinking about the tools in people's pocket, making your cell phone an extension of your daily trips, an extension of the vehicle itself to make it easier to be able to do these. And then I suspect we'll touch on it, thinking about how now that vehicle becomes a grid asset. And so it's a much different way than somebody just thinking, that's just transportation. It's much more integrated, and we have to find ways to be able to have customers essentially set and forget, walk away, and make it easy for them.
I do want to dig into some of those technical innovations and kind of grid demand response aspects that you teased out. So can you just talk about GM's work with managed charging, grid resilience, any other sort of like vehicle grid technologies that are pretty innovative and might be sort of new and exciting for our listeners?
Yeah, I think Eric started to go there, but when there's sort of two ways of looking at an EV, and they're diametrically opposed, right? There's a group of folks who see an EV and say, hey, there's some challenges with putting the infrastructure in that we have to think about. How do we upgrade the grid, make sure it's suitable for EVs? And it's certainly top of mind for every one of us who are working in it. The flip side is it's pretty neat when you start to think about an EV and how amazing it can become a grid asset now, right? And in many cases, there's not a lot of discretionary loads and loads that are this significant within your home that you can actually charge when it's good for the grid, whether it's off-peak in the Midwest because you're trying to optimize existing resources used, or if it's thinking about leveraging the extra solar. And at a very high level, when you start to think about the ability that an EV can bring to the table to help manage loads and actually manage good loads. And in this case, in your neck of the woods in Denver, the wind blows at 10 o'clock at night, right? How can we actually put together the notion that, hey, when the wind starts blowing, us and Excel Energy are starting to charge your car? So we're doing things that are good for customers, right? It's good for the pocketbook usually. It's going to be good for the environment because we can optimize those resources. But we're also doing something that's good for the grid holistically, right? We're making sure it's more efficient, generally speaking. So, we're actively working with several utilities, close to making some announcements on doing some of those managed charging. We're thinking about different types of deployment of use cases associated with it, whether it's demand response, whether it's virtual time of use, to make it easier and create, again, these grid benefits, but also customer benefits. And then, as I mentioned before, how do we make it easy for folks, right? So what if, for example, automakers and utilities were sitting in behind the scenes, meeting what your goals were, like, hey, I need my car, I need this many miles on a daily basis. Other than that, just do what you need to do to keep me charged. I come from the restaurant business and my family's got deep roots, so I always think of things in recipes. And another neat thing for folks is the recipe in Washington might be different than the recipe in Colorado, which is going to be different than the recipe in Arizona. And the fact that the EV and the utility and automaker and all these teammates can sort of work together to make sure that we design the right recipe so that it's flavorful and meets customer needs is a really neat tool.
Absolutely. And I think on that recipe front, it sort of gets at the final question I want to ask you, is just the fact that a lot of our Western states are at sort of different stages of the electric vehicle adoption and infrastructure investment within their states. And then that is, I think, doubly true for certain states and utilities starting to think about some of these grid vehicle integration technologies. Can you just quickly give maybe just one or two perspectives you have on how states and utilities can be thinking about the increased adoption of EVs in the years to come?
Yeah, I think a lot of Western states, for that matter, California in particular, has certainly been at the forefront of how to think about these things. At the end of the day, we have to open up the lines of communication between all of the parties and starting to design systems that work. And Eric sort of touched on this, and I think most folks who are listening appreciate it. This is a very complex, particularly policy issue, but regulatory, technical, commercial issue. A lot of these puzzle pieces have to come together to be able to create those recipes. And so let's open up those conversations. Let's understand regional differences or regional interests in sort of moving forward with those efforts. Let's go test. I'm not a big pilot fan, so I like to call it a big early commercialization effort, not pilot things, and start to build our understanding of how do customers engage, what are their expectations, what are the benefits that we're creating for the grid. And so we can't let that just happen. We have to be deliberate about it. Some of it's going to be a technology collaboration, right? We have to be able to put in tools that layer in the connectivity on top of it so that utilities and service providers and automakers are actively engaged. So my big push is let's have those conversations. Let's not leave it to one jurisdiction to have them by themselves. Let's start exploring and understanding what all of our needs are and how do we, at the end of the day, really satisfy customer goals.
Well, that was a great answer, Alex. And yeah, I think hopefully this initiative is one, the first of many of those conversations. And I think your comments get at how cool it is, how much integration and coordination there's going to be between public and private entities and electric vehicle manufacturers, and then, all working together to try to create a functional grid. So I think lots of exciting innovations to come, and thanks for walking us through some of those. And our final speaker is Kim Okafor. She's a strategic business development manager for Trillium, a Love's company. And Kim is going to be digging into some of the fleet and infrastructure topics that we introduced with our first two speakers. So can you just give our listeners a little bit more background about who Trillium is, and then who Love's Travel Stops is, and how they came to work together?
Love's Travel Stops or Love's Truck Stops is an over-the-road fueling provider. So we have over 550 truck stops across the country. We build around 40 to 50 truck stops a year. Even last year during the pandemic, we sat around 36 to 38 truck stops that we built. And we're still on pace to do about 40 to 50 this year. Now, Love's has a family of companies. There are multiple companies under the Love's family of companies umbrella. Trillium is the alternative fueling member of the family. So Trillium has been in the CNG space for over 25 years. Not only do we provide CNG solutions to our customers, and that includes designing and building fueling stations for our customers and for ourselves, and then operating and maintaining those stations. So we have mechanics scattered across the country operating and maintaining fueling stations for our customers and therefore ourselves. We also have a 24/7 help desk or automation desk here in Houston, Texas, that monitors all of those stations. At our 24-hour, 7-day-a-week help desk, we're able to remotely restart stations, monitor stations. If there's an issue with any of our stations, our customers call that help desk, and we answer the phone on average around 15 seconds. After 15 seconds of the phone ringing. And quite honestly, we have closer eye on the station than even our customers do. A lot of the times we know that there's an issue with the station before a customer knows that there's an issue with the station. And then we provide renewable natural gas. So that's a low carbon fuel that we can provide to reduce the carbon of the gas. And that also provides some financial incentives to our customers, such as environmental attributes and LCFS credits. And then the last part of our business, of our Trillium business, is the kind of futuristic strategic fuels. And that includes electric vehicle charging, which we have some chargers throughout our network, throughout our Love's network. We have over 70 chargers in our network. And then hydrogen fueling. So Trillium has built a hydrogen fueling station for the Orange County Transit Authority. And we're building a second station for the Champaign-Urbana Mass Transit District up in Illinois. So a lot of words, but we do everything as it relates to alternate fuels.
So one slice of the EVs landscape that I think is really intriguing for a lot of governors of states, and seeing how the medium and heavy duty long haul trucking sector with either battery trucks or hydrogen fuel cell trucks develops in the West. And so I think Love's operating travel stops and travel plazas uniquely positioned to work with that industry as it develops. And so could you maybe just talk about maybe what are some of the barriers and opportunities that exist between Love's and that developing medium heavy duty long haul trucking sector?
When we're thinking about the zero emission landscape in general, it's the age old chicken and the egg question. So the ultimate question is, do we put in hydrogen fueling stations, electric vehicle charging stations for heavy duty trucks ahead of mass production of these trucks? Well, you would think that that's an easy answer, but it's not, because there's an opportunity cost that comes with the real estate. So the amount of real estate that's required for a hydrogen station, for example, is around 5,000 square feet, depending on what type of station you're planning on putting in. So what is the opportunity cost of that real estate? Is there something else that we can be doing with that real estate between the time where we're at that now and mass production, that would be more advantageous for us to get a better rate of return on that land. Another barrier is when you think about the travel stops, we're not in downtown LA, we're not in Houston, Texas, we're kind of in the middle of nowhere areas of the country. And the difficulty that comes along with that is really comes down to utilities. Are we able to get the amount of electricity that's required, or whether you're talking about a hydrogen station or electric vehicle station, to these truck stops, to these travel centers in a timely manner? So working with utilities early is something that we're trying to understand, and trying to understand what all of our options are. So should we have some on-site power generation? Should we have on-site storage, energy storage? So we've started learning about that market, right? We put in solar arrays at, I think we're about 6 or 7 truck stops across our network. We've put in an on-site battery at one of our solar arrays in Corning, California, so that we can understand how these things really operate. So I would say the 2 major challenges that we keep in mind is how quickly should we be providing these fueling solutions in order to get a rate of return that makes sense? And then how do we get the amount of energy that's needed in order to fuel these zero emission trucks in a way that meets the time commitments that we need?
Can you talk about how Trillium helps prospective or current fleet owners kind of decide what fueling system is most advantageous and least costly for their needs, and what are some of the specific factors that determine those costs?
I think one thing that helps us with discussing these things with fleets is that we have our own network of fueling stations, right? So we understand the barriers of entry when it comes to whatever fuel that they're talking about, whether it be CNG, EV charging, or hydrogen fueling. So having that perspective is extremely helpful. But when we're talking to fleets, some of the things that I like to put in the forefront is understanding their real estate. So with hydrogen, it's easier to understand, especially if you have a CNG station or quite honestly, a diesel station, because everything is kind of consolidated in one area. So you have your tank, your compressors, your liquid storage tank, your high pressure storage tank. You have your dispenser kind of separate. So it's set up in a way that's more familiar to fleets. Now, when you're talking EV charging, you have little chargers scattered across your depot. Now, are you able to work in that manner? That's something that the fleet would have to consider. Or do you have trust in your drivers that they'll be able to maneuver around these things? It's difficult, especially if you're driving a 60-foot bus. That's not easy to do. So understanding the challenges that come along with real estate, and then the money piece, right? And a lot of times when we think about fueling infrastructure, a lot of folks just think about the CapEx. You say, okay, I'm going to put in one charger, easy enough. There's also the OpEx related to it, right? And not only the maintenance, because the maintenance of a charger, similar to what Alex was saying, you really think about it like charging your phone. You just kind of plug it in, you step away and you go. But you have to think about not only the maintenance of the equipment, but also the utility bill. Do you have a demand charge in your region? Is there a better time of use or a better time to be charging your buses or your fleet based on the time of use of your electric bills or your electric tariff? So understanding the different pieces of the OpEx and the CapEx associated to the fueling infrastructure that you're considering. And then the last thing, and I brought this up before, and I think it's worth bringing up again, it comes down to your utility. So if you're considering putting in a charger, but you think you're going to transition most of your fleet to battery electric, do you bring in enough power for that one charger, or do you plan for the future? Do you bring in enough power now for 50 chargers so that you aren't doing another upgrade in 2 years? Or do you do upgrades along your transition period? So it really comes down to real estate, finances, whether you break it up into CapEx and OpEx and thinking about both sides, and then early engagement with your utility and determining what process you would want to take there.
Yeah. What we've learned from our fleet conversations really aligns with that, in that these costs are hyper local, down to those local utility rate structures. And then what is the terrain like around that fleet? Is it really hilly? And how does that tie into fuel consumption or electricity consumption and everything? So yeah, it can be certainly hard to generalize some of these costs. But Kim, I want to ask you one more question, which is essentially just about grants and public funding opportunities. I think that a lot of individuals, maybe states, are familiar with the fact that, oh, if you buy an EV, you might be eligible for some sort of rebate, or when you buy the car, or when you do your taxes, whatever it may be. But could you go into some of the funding opportunities for EV fleets and how you all work with those?
Definitely. I think one thing that comes along, and it goes back to us having our own network of fueling infrastructure, fueling stations, is I even have to apply for grants for my own stations, right? So if I want to put in an EV charger, there's so much money out there that it doesn't make sense for me to be paying for the infrastructure at cost. I should be applying for a grant, and I have been for my own infrastructure. Now, thinking about our fleet partners, so transit agencies, municipalities, refuse fleets, and things like that, the short answer is there's money out there. And if you're thinking about going zero emission, understand what options you have, whether it be state money or state grants or federal grants. I know one thing for transit agencies is they have the Lono grant every year, and that's a federal grant that's offered to public fleets. So understanding what's offered, what are the requirements associated to it, reaching out to your fueling partners, folks like Trillium, so that we can help you come up with a budget for how much you should be asking for, understanding what the match share is. But grants aren't your only option. So Trillium, we do public-private partnerships with our public customers. Essentially what that is we would come up on some or all of the capital for the fueling infrastructure for our public customer or public partner, and that partner would pay off the infrastructure over an agreed upon term. Now it's a contract, right? So there are some stipulations. You have to, transition over a certain amount of time, use a certain amount of fuel and things like that. But I say that to say there's a lot of grant money out here, but there's only so much. So think about what other options you have. You could talk to your utility. There are a lot of, especially electric utilities, that are providing ways for fleets to get their infrastructure at a reduced cost. And there are ways to help you transition your fleet to zero emission, and just doing some research to see what's the best option for your fleet is something that I would recommend.
Well, Kim, that was a really good response. I think, your discussion of funding opportunities and just seeing what's out there does kind of tie into this whole innovation frame, and the fact that electric vehicles and electric vehicle fleets are leading to a lot of innovative partnerships between site hosts and electric vehicle charging operators and utilities and private industry. I think that's where a lot of the excitement in this sector is. But I would like to key in on one particular project that you all were involved with, which is a hydrogen fueling station renovation for the Orange County Transportation Authority in Santa Ana, California. I understand that this is one of the largest hydrogen fueling stations in North America. So if you could go into that project, what some of the costs and challenges were, and how the station functions now, that would be awesome.
Of course. So the Orange County Transit Authority, OCTA, is a longtime partner of Trillium's. We've been their fueling partner for several years now. In fact, we've built 3 of their CNG facilities. We operate and maintain 3 of those facilities as well. So it was kind of a natural response whenever they came out to bid for their hydrogen fueling station. That was actually our first time bidding on a hydrogen fueling station, because we had noticed that our customers were asking us these zero emission questions. So it was kind of a natural fit for Trillium to work with OCT on this new fuel. It was new for the both of us. So as you can imagine, there are a lot of lessons learned. But it was a really good opportunity for us to enter the market. I think some of the things that we learned that we weren't expecting to learn was that AHJs, this is a new fuel for them. So local authorities having jurisdiction, a lot of them haven't dealt with hydrogen before. So getting them involved early and often is advantageous to make sure that the project is moving in the right direction. We put the hydrogen fueling dispenser in the same kind of fueling building as the CNG dispenser. So now the question is, if something's going on with the CNG station and there's an alarm situation or an emergency shutdown situation at the CNG station, should the hydrogen station shut off as well? Thinking about the emergency situations associated to both stations, when you have a depot and you have multiple fuels at this depot, understanding how you want your emergency operation scheme to be and to act. With our hydrogen fueling station, there's a capital piece, there's an operation and maintenance piece, and then there's a fueling piece. And the tax regulations or the tax rules for each piece is different. So understanding those tax pieces is something that we learned. Luckily, because we are a part of a multi-billion-dollar company, and Loves has a tax team monitoring all of the 550 stations across the country, they also monitor our stations. So now we've implemented a process where we have a tax memo that comes out for each station that we bid on. And that includes the memo for the fueling piece, or for the fuel, for the capital, and for the operation and maintenance. So that tax lesson was something that I wasn't expecting to learn, but I know a lot more about tax than I care to know, honestly.
Can't say I'm too jealous.
You should not be jealous at all whatsoever.
Great, thanks, Kim. And then just one final question for you. Having worked on that hydrogen project, do you think that there are any slices of the EV landscape, whether it's in the transit agencies particularly, or long-haul trucking, or municipal trucks, or whatever it may be, where hydrogen and fuel cells could carve out a niche?
I do. So I should say that I serve on the California Hydrogen Business Council. I serve on the board of that council. Here's what we as an organization kind of believe. One, we don't say any fuel is the winner. Whatever fuel makes sense for our customer, that's the fuel that we're going to provide them. We think that there's space for all fuels. So what we really think about in the future, whether it be 10 years from now or 20 years from now, there could be a truck stop of the future that has diesel, gasoline, hydrogen, EV charging, and all the other fuels under the sun included all at one station. I think there's a slice of the pie for both zero emission fuels. When we think about our network, our customer base, the Trillium customers are usually a return to base sort of customer. Now, when we think about the Loves customer, that is a cross-country Class 8 long-haul customer. So without advancement in battery technology, it may be difficult to make battery electric trucks go long-haul. But the big caveat there is the advancement of battery technology. Who knows what the battery is going to be like in 5, 10, 15 years. There's so much advancement in the battery. So it would be easy to say that the short haul customer would be a battery electric customer and the long haul customer would be a fuel cell customer. But that's sitting from the vantage point that we're at now. Perfect example, if you think about phones. 10 years ago, our phones did not do as much as they do today. I say all that to say technology advancement makes you work in a different way. So things will change as technology advances. And I'm sure that the trucking market is no different.
I think one challenge for states and governors and local agencies is just the pace of change within the sector. And there are always advancements in batteries and other technologies and charging and fueling systems. And sometimes it can be hard for them to keep up and think like, well, what do we fund this time? Like we did this last time, but does this make sense again? And I think all of those innovations are just really fun to watch. And Kim, thanks so much for sharing a few from your world. And we just really appreciate you taking the time today to talk with us.
Thanks for listening to this episode of Out West. Be sure to join us for our next episode of Governor Brown's Electric Vehicles Roadmap series, when we will discuss economic development in the EV space. Finally, WGA would like to thank Eric Wood, Alex Keros, and Kim Okafor for sharing their expertise on EV innovations and technology advancements in the West. Happy trails, everyone.